Maybe we will in a little bit. Here we go. Notes 15, Implicit Diff, Part 2. So after today, you will be beast, and we will go into related rates. Disclaimer, when you do your delta today, delta is really big on writing y prime for dy dx, and then substituting at the very end. I would recommend you don't have that habit of writing y prime. Let me tell you why. Y prime a lot of times looks like y to the power of 1. And when we do related rates, you're not going to be writing y prime, m prime. You're going to be writing with respect to what? Like right now we're taking derivative with respect to x. In a little bit we'll do something different with respect to y. But when we do related rates, like what's the rate of change of a circle with respect to area? With respect to the radius, you're going to be writing dAdr. Do you guys know what I mean? So try really hard when you do your delta in a little bit to not get that habit of writing y prime, of writing dy dx. All right, here we go. So we already know the difference between explicit and implicit. We did that. We showed you that those derivatives were the same. And for the first examples, we can take a derivative with respect to any letter. It doesn't have to be x. So d dy. So notice I'm taking the derivative with respect to what letter? The y. So if I'm taking the derivative with respect to y, so let's see, what's the derivative of 2y cubed? Yeah, and if you want, you can write dy dy, but dy dy is the same thing as 1, so that's why we don't write it. And then what's the derivative of 5 cosine y?
Negative 5 sine.
There you go, and that's it. If it was with respect to x, we would have written a dy dx after each one. Does that make sense? All right, look at the next one, letter B. I think you guys already got the hang of it. I'm taking the derivative with respect to what letter? U. So what's the derivative of 5u squared? 10u. And what's the derivative of cosine? So plus 3 sine u. You do not have a du dx because you're not taking the derivative with respect to x. You're taking the derivative with respect to u. So if anything, it would have a du over du, but that's just 1, so you don't write it. Are we cool? All right. Now here we go. This is a question. I want dy dx. So this is what you guys are accustomed to. I'm going to take the derivative, but notice there's a whole bunch of stuff happening. You guys ready? And we're going to go slow. So let's start. Oh, the habit that you guys had, one of you had this habit. You immediately write dy dx, and then you put an equal sign. Do not do that. It does not say y equals anything. I put a dt there instead of x. Okay, my bad. All right, what's the derivative of 10? So write secant squared, but you're not going to write x. You're going to write what argument? xy. You're not done. That's the derivative of the outside. Now I got to do the derivative of the inside. So giant parenthesis. What rule do I got to use for that? Product. First times derivative of the second, dy dx, plus second, derivative of the first. The derivative of x is just 1. Leave it alone. So then close it. Equals, what's the derivative of x? 1 plus, what's the derivative of y? Dy dx. You are done with calculus. Everything else is algebra. What you're trying to solve is dy dx. I have a product here. So yes, you could technically divide, but I think that makes it harder. Yes. Do which one? Oh, the derivative of x with respect to x is 1. d dx of x, that's just 1. And then the derivative of y with respect to x is dy dx. So derivative of x is 1 plus derivative of y dy dx. Well, the derivative of tan is secant squared. And the xy is the argument. And then chain rule times the derivative of the inside, so which is this parenthesis here. We feel okay? First, x times derivative of the second, product rule. Derivative of the second is dy dx, plus second, the y, times derivative of the first, which I guess technically there's like a 1 right here, but you don't need it. I don't know if I answered your question because I don't know if I heard. Say that again. Oh, to get this one right here? Yes. That's the derivative of x. I'm in the right side. I'm looking at the right side now. What's the derivative of x? You see it? Okay, are we good now? Yeah, no, I'm on the right side of the equal sign. So the derivative of x is 1, derivative of y is dy dx. Okay, are we okay so far, guys? All right, here we go. No more calculus. Everything else is algebra. I'm trying to solve for dy dx. You could make a case for dividing by secant squared and then moving the y, but then it creates more. In my opinion, it creates a mess. I'll show you what I mean later on. I'm going to distribute this like so. Do you guys see that? So here we go. I'm going to write this up first. X dy dx. I guess it doesn't matter. X dy dx secant squared xy plus y secant squared xy. Is anyone confused? Are we okay? All right. Everything that has a dy dx, I'm moving it to the left. Whatever does not have a dy dx, I'm moving it to the right of the equal sign. So here we go. I'm going to leave this one alone. X dy dx secant squared xy. And I'm moving this dy dx to the left here. So minus dy dx equals, everything else does not have a dy dx. That one there, and I'm going to move this one to the right. Minus y secant squared xy. Is everyone okay so far? Yes. Now that I grouped the dy dx's in the left, that is what I'm going to factor out. So here it is, factoring out dy dx. I was already going to solve it. Parenthesis. I'm left with x secant squared xy minus, if I factor out a dy dx from dy dx, that's a 1. Are we okay so far? And now to get dy dx, I gotta do the quotient, or I gotta divide by x secant squared xy minus 1. So here's what you finally have. Dy dx equals, in the top I have 1 minus y secant squared xy. In the denominator I have x secant squared xy minus 1. No, they do not cancel. Do not cancel anything. That is my dy dx. How do we feel? Nah, you can leave it there. Everything's in terms of x and y. You feel okay, Abdul Kareem? Let the record show that Abdul Kareem says she feels okay. All right, here we go. It says for the relation square root of x plus y equals 3x, find the value of x for which dy dx equals 17 when y equals 8. You guys ready? So what I need to do is take a derivative. I'm going to plug dy dx equals 17. I'm going to plug y equals 8. And I'm only going to be left with an x. So then I'm going to solve for x. Does that make sense? All right, I'm going to rewrite it. I haven't taken a derivative yet. Here's me rewriting it. X plus y to the half equals 3x. Are we okay right now? All right, let's take a derivative. What do I do first? 1/2 x plus y to the what power? Yeah, a lot of times you guys forget that. Am I done? Times derivative of that inside, which is 1 plus dy dx. Perfect. Close it. Equals 3. Can everyone get to there? Perfect. Then you're winning. I'm going to make it pretty. This is in the numerator that I'm underlining in blue. And what I'm underlining in green is in the denominator. That 2 and this. So here we go. Here's what I have. 1 plus dy dx over 2 square root of x plus y equals 3. I think it's easier to plug in y equals 8 and dy dx equals 17 and solve for x from there. I think that's easier. If you want to get x by itself, I know physicists like to do that. They like to isolate the variable and then plug in. That's fine too. I just think it's easier to manipulate numbers once you put them in. So here we go. I'm going to put them in. I'm going to say insert. Insert y equals 8 and insert dy dx equals 17. So I'm going to write 1 plus 17 over 2 square root of x plus 8 equals 3. 1 plus 17 is just 18, so let's see. 18 over, and I guess, okay. In my head, I'm trying to do like 2-3 steps at a time, but I realize you guys want to see step at a time, so there it is. I just did one step. I'm going to multiply by the denominator. So I'm going to have 18 equals 3. Well, 3 times 2 is 6. So is it okay if I write 6? 6 square root of x plus 8. Does everyone know where the 6 came from? Okay, I just multiplied everything by 2 square root of x plus 8. Left and the right. Now I'm going to divide by 6. And 6 goes into 18 how many times? So I'm going to write 3 equals square root x plus 8. And now I'm going to what? Square it. Square. So 9 equals x plus 8. And then the last thing. Oh, what's up? I multiplied this by 2 square root of x plus 8. Whatever you do to one side, you do to the other. And you can see 3 times 2 is 6. So that's how I got that. X equals 1. How do we feel, guys? Any questions on this? Are there any errors? I don't see any. What's up, Gonzalez? Because I wanted to solve for x. I can't solve for x when it's in the bottom there. And since I already had a 2 in the bottom, I mean, I guess you didn't have to, miss. You could have just, like, if you wanted to, you see how I'm writing that right there? You could have said 9 over square root of x plus 8 equals 3. And you could just multiply by square root of x plus 8. You would have gotten the same answer. 9 equals 3 square root of x plus 8. See? Divide by 3, divide by 3. 3 equals square root of x plus 8. You would have gotten the same thing. Yeah. Yeah. So you don't have to multiply by 2 square root of x plus 8. You could have reduced 18 divided by 2, which is 9. So that's the beautiful thing about math, about algebra. You can do it many different ways. Cool? All right. Here we go, guys. This one again, it says find dy dx. So you guys ready? And in terms of x and y, all right, here we go. You guys tell me what I do first.
6.
Perfect.
Then the inside. So times 1 plus 2y dx.
Perfect. All that equals
2.
2. So I'll wait for everyone to catch up. Is everyone okay with that first line? The most common mistake is that you guys write y prime on the side and put an equal sign. Do not do that. Or you put dy dx on the side. We're doing this implicitly. That's only for explicit. Okay. You're done with calculus. Everything else is just what now? Algebra. So if you want, you can move that 6 to the right, which I think it might be easier, and then distribute this that way, or or leave it there and have everything in terms of 6. What do you guys want to do? It doesn't matter. Okay. If I divide everything by 6, divide by 6, divide by 6, on the right hand side, I'm going to write x plus y to the 5th power, 1 plus dy dx equals 1/3. Does everyone know where I got that 1/3? Okay. I'm going to distribute this to the 5th power like so. How do you do that? Like this. X plus 5 to the 5th power times 1 is x plus y to the 5th power. You guys see that? Plus x plus y to the 5th power times dy dx is x plus y to the 5th power with a dy dx on the side. Equals 1/3. Are we still okay? Yes. Side note, this is like saying if I had something like a to the 5th power times 1 plus b, I just did a to the 5th power plus a to the 5th power b. Does that make sense, Tovar, or no? I'll say it slowly. I have x plus y to the 5th power. Anytime I multiply that by 1, you're just going to get itself. So that's why I got x plus y to the 5th power. And then x plus y to the 5th power times dy dx, x plus y to the 5th power with a dy dx on the side. Does that register or no? No? Well, because it's like saying the b. See, this b doesn't have a 5th power. So the b is like the dy dx. The a has a 5th power. So a to the 5th power times b. The power stays with whatever letter you have. Now, if you would have had a to the 5th times a, then that would have turned a to the 6th. But I don't have that. They're not the same like terms or, the same base. So x plus y to the 5th power times dy dx, the 5th power just stays with the x plus y. Are we cool? Or we can talk later. All right. I don't have a dy. I need to get the dy dx's by itself, guys. So remember, we're done with calculus. Move this one to the right. So we're going to have x plus y to the 5th power dy dx equals 1/3 minus x plus y to the 5th power. Are we still okay? And now to get dy dx, I'm going to do what? Divide. Yeah, so dy dx, here's how it's going to look. 1/3 minus x plus y to the 5th power over x plus y to the 5th power. And I know you have a fraction with a fraction. I think that's called an improper fraction. But it's perfectly fine. You can leave it alone. That's the correct answer. I don't see any errors. If you don't like that 3 there, then I guess I could have done a common denominator times 3 over 3 times, and then I could have brought that 3 down, but I think that's perfectly normal. That's fine. Are we okay, guys? All right, here we go. Example 5. Find dy dx at the point 2, 1. You guys ready? What is the derivative of y? Dy dx. All right, dy dx minus, what's the derivative of 4y cubed with respect to x? Perfect. Plus 2x. Are we still okay, guys? Equals the derivative of negative y squared. Plus 1. You're done with calculus? Algebra time. Get all the dy dx's on the left, everything else on the right. So I'm going to put this one first because I like to have a positive expression. 2y dy dx minus 12y. Oh, I already had a dy dx over there. Darn it. Sorry, guys. Plus dy dx minus 12y squared dy dx equals, I'm moving that 2x to the right, so 1 minus 2x. I don't see a mistake. I should have written dy dx in the front, but no big deal. I'm going to factor it out. I just wrote this one first because it was negative. And I know I already had a positive expression. This dy dx is this one. Yeah, anytime you move it to the other side of the equal sign, it changes signs. Are we okay? Factor out a dy dx on the left. So when I do that, I'm going to have 2y plus 1 minus 12y squared. Well, I'm going to rearrange that a little bit. Equals 1 minus 2x. Are we still okay? I'm going to divide by that expression, because there is a product. So dy dx equals 1 minus 2x over, I'm still going to write the 2y first. 2y plus 1 minus 12y squared. The only reason I did that, let me do a side note. If you were to have done this, sometimes this negative floats. I mean, I guess right here it looks okay. But sometimes some of you will do this. If you put it far enough to the back, that is no longer correct. You're telling me the whole expression is negative. Does that make sense? So you just got to be careful with that negative. So that's why we like to put positives in the front. All right. I think we're done. We just got to plug in. dy dx, start a new line. Put a line like that. It means evaluate it at. And put 2, 1, the ordered pair. And just plug in. 1 minus 2 times 2 over 2 times 1 plus 1 minus 12 times 1 squared. So let's see, 1 minus 4, that's negative 3. And then 2 plus 1 minus 12. 3 minus 12, is that 9? Negative 3 over negative 9, so 1/3. How do we feel? So those of you that are thinking, when will I ever use this? Look, guys, there's some calculus in here. You see this ocean service? All right, let me see if I can click on it. Nope, I can't click on it. All right, no big deal. Look at this. I have it right here, guys. OneDrive, Math Life, Calculus, 2022-23, notes. And look at all the notes we've done so far. I only have it organized because I'm sharing this with everyone else. So here we go. Look at this calculus stuff here. How do I go to it? I can't push control. Hold on. Let me push control. Control. Copy. Paste. Sorry, guys. This is taking longer than necessary. Paste. How do I hit enter? Go. Look, sea level is rising at an increasing rate. What does that mean? What does it mean for sea levels to be rising at an increasing rate? Yeah, it's every year. Not only do sea levels rise, so if it rose 1 inch this year, next year it rose 2 inches. The year after that it rose 3 inches or whatever. It could be concave up or concave down, but we know it's rising at an increasing rate. It could be like that or it could be like that. Isn't that cool? Okay, I thought it was cool when I saw this, and this is important because it's the future. You could be the engineer that's doing this study right here. You can be the scientist that's doing this. All right, I thought it was cool, guys. All right, here we go. This is what we're going into. Have you seen? All right, guys, real quick. This problem is so popular in physics, like it comes out all the time. I think professors use this question to see if you're worthy for honors or something or whatever. Look at this question. It says that 13-foot ladder is leaning against a house. When its base starts to slide away, by the time the base is 12 feet from the house, the base is moving at a rate of 5 feet per second. Do you guys want to see if we can tackle it now with what we know? All right, look at this. First, we got to come out with a relationship. So here's what's happening. So as the ladder moves to the right, this is moving down. And what do they want to know? The base is moving at the rate. By the time Do they want to know anything? When its base starts to slide, by the time the base is 12 feet from the house, the base is moving at 5. I didn't ask a question. Dang, that sucks. Okay, let's just start with like doing basic stuff. We can ask so many questions here. We can say, what is the rate of change of this area in here? We can say, what is the rate of change of the angle? We can say, how fast, do they give me, what did they tell me? They only tell me how fast I'm moving. Okay, I can say, how fast is it sliding down? Because I don't know how fast it's sliding down. I know how fast it's moving to the right. The base is moving at a rate of 5 feet per second. So if this side right here moves 5 feet per second, does that mean that this point right here is moving 5 feet per second down? No, it's not a linear relationship. It's not one-to-one. So this is why calculus is needed, guys. You guys don't think this is cool? Okay, look, real quick, and then we'll stop and then we'll let you guys go to your delta. So what's the relationship that puts all three of these together? That puts side X, side Y, and this 13-foot ladder together? Yeah, that's what Pythagorean theorem. So we would have written like this. This is the hardest part of calculus, is creating a model. So now you're seeing the real part of calculus, like why calculus is so strong. That's the hardest part. If I want to find a relationship between dx dt and dy dt, guess what I'm going to do? I'm going to take a what? A derivative. And look at this. I'm going to take a derivative not with respect to x and not with respect to y. I'm taking it with respect to t, time. Do you guys see that? Because that's how they're connected. When, like, what you'll see. Watch. Take the derivative of x with respect to t. What do you get? 2x dx dt plus, what's the derivative of y squared with respect to t? Equals, the derivative of a constant is 0. Now, guys, I don't want you to be robots. All this makes perfect sense. If the ladder is a 13-foot ladder, let's say I would have put z here, z. Then I would have said dz dt. But look, is the ladder moving? So dz dt would have been 0 anyways because the ladder is not moving. Like, it's not getting larger. It's like, oh, it's 13 feet now, and after I slide 5 feet, now it's 15 feet ladder. It's not getting larger. It's staying the same speed, the same size, the ladder. Does that make sense? The ladder is moving, but it's the dz dt. This is side z. Is the ladder getting bigger? No, it stays at a constant. So that's, even if I would have put a z there, I still would have gone to 0. See? This dx dt, I want you guys to recognize and see how powerful this is. That dx dt means motion in the x direction. It's how fast it's going. This dy dt is motion in the y direction. Now notice the relationship. If I were to solve for dy dt, I get a negative. Travis, what are you talking about? If I move this to the right, so 2y dy dt equals negative 2x dx dt. Is this a shocker to you that you get a negative? No, because it's moving down. It's a vector. Do you guys see that? Or do you guys not see that? Okay, this is what we're going to in the future. In a little bit, I'm going to let you do your delta. Don't get the habit of writing y prime. Maybe it makes it easier. Don't get the habit of writing y prime, guys. Continue with the dy dx. Cool or not cool? All right, perfect your skills. It's just a delta assignment. Go ahead and finish it. And we are done with today, guys. Hopefully you learned something.